eli5 does every part of a ball spin at the same speed. The entire ball is spinning at the same speed in terms of rotations per unit of time. At the surface level, different parts of the spinning sphere are moving at different speeds. The equator will be moving the fastest. The poles, where the surface meets the rotation axis, will be moving slowest. On Earth, the equator travels Earth's full circumference 40,000 kilometers or 25,000 miles per 24 hours. The geographic poles move 0 kilometers per 24 hours. It's essentially a gradient of different surface speeds as you go from the poles to equator. It all happens in one rotation per 24 hours. Radially d in radians, yes. The Earth rotates at pi 12 radian h anywhere along any axis. Linearly d in meters, no. Any point on Earth rotates at r pi 12 kilometers height, where r is the straight line distance from said point to the north-south pole axis. Except anywhere along the north-south pole axis itself. Those do not move through space at all, so their speed is 0 radian h and 0 kilometers height because r0, if you don't take into account the fact that the Earth is orbiting the Sun, and the Sun is orbiting Sagittarius A, and the universe is expanding, of course. Take a look at a bike tire or any other wheel. Mark a point on it close to the axle and another point on the tire. Spin the tire. You will see that both points cross their original positions at the same time. Now consider the circumference of the circle made by the point close to the axle. It is much less distance than the circle made by the point on the tire. Therefore, the further the point is from the axis, the farther it has to travel for one full spin. If it does that in the same amount of time, it must be traveling faster. Take the sphere. Then imagine an axis, like a cylinder rod, passing through the middle of the sphere. The farther you are from that axis, horizontally, the faster you will go, because you'll need to cover the same angle at the same time, but in a greater perimeter distance. The closer you are to that axis, the slower you move, because the perimeter is smaller. All parts of the sphere rotate at the same time, but specific points in the circle will be faster or slower depending on how far away from the central axis they are. Every part of a solid sphere rotates at the same angular velocity. For the Earth, this means that every part of the planet, regardless of latitude, rotates at 15 degrees per hour. However, because lines of latitude are parallel, their circumference gets smaller as you move towards the poles. This means that the distance, in miles, that a degree represents gets smaller as well. So, as you move towards the poles, the linear velocity at a particular latitude gets slower so that the angular velocity remains the same. Yes and no. From a scalar speed perspective distance time, the answer is no. As you surmised, close to the pole's axis of rotation the amount of distance covered in one revolution is less than at the equator. Therefore the tangential speed is higher farther away from the poles. But from an angular rotational speed perspective, the answer is yes. Each part of the sphere completes one rotation 360 or 2 pi radians within the same time, so that will be constant throughout the whole sphere. Yes, it is. That's why rotation is measured in things like revolutions per second or radial speed. Saying that a ball is spinning at 10 kilometers per hour doesn't make sense unless you're talking about a specific point on the surface. For example, the Earth is roughly 25 km at the equator and turns once every 24 hours. So the land at the equator is going about 1,000 miles per hour, but a foot from the axis of rotation travels about 614 feet in one whole day. Yep. I'm not a physicist or anything, but in my head I'm almost certain that they do. Imagine you put a dot on the equator of the ball and a dot directly above it near one of the ball's poles, and you spin it. If different parts of the ball spun at different speeds, both dots would eventually become misaligned, but obviously they don't. Both dots stay in the exact same position relative to each other during the entire spin. Yes and no. The yes, every atom of the ball is spinning at the same rotational speed. The no, the atoms further from the center are moving faster than the ones closer, they cover more distance in the same unit time. The atom exactly at the center of the spin is not moving in space at all, only around its own axis. So, depending on what speed you are measuring, the answer is yes or it is no. Yes. Every point in a ball's surface except for poles goes around the axis making a circular orbit. The diameter of this circle is smaller closer to the axis and bigger further. Every point moves around with the same speed, but the ones further has a longer route to do in the same time amount, thus has to move faster than the closer ones. Another way to look at it is at a racetrack. If everyone started off side by side and ran at the exact same speed, The people closer to the middle will finish one revolution or one lap before the person on the outside. If they were to lock arms and run, the people further out would have to run faster to keep up. The entirety of the ball rotates at the same rate. The ball's surface moves fastest at its equator, slowest at its poles, just like the Earth. At the equator the Earth is moving at around 1,000 miles per hour or so. At mid-latitudes where most people live it's about 800 miles per hour. At the poles it's zero. Yes. Imagine you spin a chain around above your head. When it makes one full spin, every link has only gone around once. Links by the hand have traveled less distance than those at the end. So those at the end must have been moving faster to cover more distance in the same time frame. Nobody has mentioned the Coriolis effect. What you say regarding the speed in Ecuador is correct and generates a very interesting effect called the Coriolis effect in general terms due to the difference in speeds and the different latitudes. Look it up, it is very interesting. No, it's why launching space-bound rockets from near the equator, i.e. French Guiana, is so popular and why nearly all space launches head east. You gain several hundred miles per hour of orbital speed for free when you do. If you are talking about linear velocity ms, yes, the outer the edge, the faster. But if you are talking about angular velocity change in angle over time, measured in radius, then they are all the same. Simply put, yes. The angular velocity RPM is the same obviously, but at different points equator the path of one rotation is longer and hence its actual speed is higher than at other parts. Points closer to the axis of rotation move slower for the same angular speed, points on the axis are immobile. Linear speed, angular speed, distance from the axis. This is why most rocket launches are near the equator, and launch in the same direction. We get a big speed bump from equatorial launch speeds. Doesn't it matter if we're talking about a solid? A rubber ball is easy, but a multi-layered planet with straight gases etc. is there some variation? Calvin's dad explains this well in this Calvin-Hobbes strip. 3a2f. Every part of the ball has the same angular velocity, but the linear tangential velocity is lower closer to the axis of rotation. Relevant explanation regarding car wheels from Neil deGrasse Tyson. Correct. That is why in physics rotation is measured in both radians second and actual velocity at a point.